Let's begin the second half or part of this lecture by talking about the naming of compounds that have metal ions that can have more than one charge. Many of the elements in the transition, which is the middle part of the periodic table, have more than one ionic state. For example, iron can either give up 2 electrons and be +2, or it can give up 3 electrons and be +3. Similarly, tin can give up 4 electrons and be +4, or it can only give up 2 electrons and be +2. The names of these has to include some way of distinguishing which of these two metals ions we're talking about. And so what is now used is something called a Roman numeral. It used to be that each of these had a different variation to the name. For example, instead of being called iron, it was called ferric sulfide and ferrous sulfide, stannic sulfide and stannous sulfide. But now instead of doing that, they use iron 2 and iron 3, tin 4 or tin 2. And the Roman numeral tells you the charge on the cation. So you'll have iron 2 sulfate or tin 4 chloride. Now iron 2 sulfate used to be called ferrous, O-U-S, ferrous sulfate. So you may see that name sometime in older books. Tin 4 chloride used to be called stannic with an IC chloride. So let's do a few examples of this. So let's give the name of each of these various compounds. So first we have Cr, which is chromium, and it's combined with the sulfate polyatomic ion. And we know that sulfate has a charge of -2, so this has to have a charge of +2. So this is going to be chromium 2 sulfate. This next one, CO, if you look on your periodic table, that's cobalt. And the phosphate, you can look up on the table, this is a -3, so this is -6. So if you divide 3 into 6, you see that this has to be 2 as well. So this is also cobalt 2 phosphate. The third one here is iron and then hydroxide. And you know from your table again that hydroxide is a -1, so this iron has to have a charge of +3. So this is iron 3 hydroxide. Let's look at the other side here. This is gold, and they're telling you that it has a charge of +3 with iodine. So it's Au and iodine, and they're telling you with this Roman numeral that this is +3. We know this is minus, so the least common multiple is 3, so 1 goes into 3 times. So the formula for this is going to be AuI3. Mercury 1 oxide, we've got mercury and oxide. This is -2, and this 1 tells you this is +1. Again, 2 is the least common multiple. 2 goes into 2 1 time. 1 goes into 2 2 times. And so it's going to be Hg2O. Iron 2 sulfate. It's iron and sulfate. We know this is -2 from the table. And this is telling you this is +2. So it's going to be iron sulfate. Iron 2 sulfate. Now, we have to move on and talk about acids, what they are and how we're going to name them. And I'll tell you, we'll have a whole lot more to say about acids in the future. But an acid is the compound where one of the two elements, a binary acid, a binary compound is a compound that has two elements in it. A binary acid is where one of the two compounds is hydrogen. And the way these are named is to use the word hydro followed by the name of the anion with the IC suffix. For example, HCl, the anion is chloride, so it's hydrochloric acid. HI, again, I is the anion, so it's hydroiodic acid. Oxyacids are acids that have hydrogen, oxygen, and at least one other element. So they're compounds that has hydrogen, oxygen, and at least one other element. So you start with the root name of the anion. Just like up here we had chloric. Well, you start with the root name of the anion and then add IC, ITE, or OUS depending on whether it's the most negatively charged it could be, a middle, or the least negatively charged it could be. And then the word acid. So for example, HClO4, there's actually 4 possibilities here, so the little per is put in for that 4th possibility. HClO3 is chloric acid, HClO2 is chlorous acid, HClO is chlorous acid. HNO2 is the middle, so it's nitrous acid. This first one here says give the names of each of the following. HI, we've already done that. HI is hydroiodic acid. The second one here is H2CO3. You look in your table, and this is the carbonic radical, or carbonic polyatomic ion. So this is carbonic acid. This is also called carbonate. This polyatomic anion. The third one here, H2SO3. Okay, again, if you look at your book, this is the sulfite polyatomic anion. Now, therefore, it's sulfurous acid. If this was a 4 and it was sulfate, it would be sulfuric acid. Give the formula for each of the following. Hydrofluoric acid, HF. Phosphoric acid, phosphorus is PO4. It's -3, so you need 3 hydrogens to balance that -3. So H3PO4 is phosphoric acid. Nitrous acid is the NO2 minus group, so it's HNO2. Naming binary compounds is actually quite simple. Binary compounds are compounds that contain 2 elements. Binary compounds are compounds that contain 2 elements. The name of the first element is left unchanged. The name of the second element is the suffix IDE. We've talked about this already. So sulfur dioxide is SO2. Carbon tetrachloride, CCl4. Now, where did this di and tetra come from? Prefixes, look in table 2.10 in your book, are used when more than one possible compound exists for the 2 elements. So, for example, the top one, sulfur dioxide, in nature there's also a sulfur trioxide. So the di is included to tell you that there are 2 oxygens. Now, if there were only one possible sulfur plus oxide, then it would just be called sulfur oxide. But because there can be two, actually one, two, or three, you include the dye to tell you that that's the sulfur oxide compound you're talking about. Similarly, carbon tetrachloride, there are other carbon chloride combinations, and so you use the tetra, which means 4, to tell you that there are 4 chlorines. So this is another example. There's carbon monoxide and carbon dioxide. So you have to use mono and di to tell you that there are more than one possibility. So let's look at some examples here. Just give the names for these. There's the first one here is P2O5, and this is actually interesting because you have both require a prefix. So in this case, you have diphosphorus pentaoxide, or pentoxide. This A is not necessary. It's just pentoxide. The second one, NF3, is nitrogen trifluoride. Now you notice that these are situations where you're not ionic in nature. You're combining two nonmetals, nitrogen and fluorine, are both on the right side of the periodic table and very close to each other. And so because of, you'll notice that, and that's when you have to use these prefixes, is when you're dealing with compounds like that. This is SiCl2. There is an SiCl4. So this is silicon. Not a very good writer, sorry about that. Dichloride. And that's to differentiate from silicon tetrachloride. So nitrogen tribromide would look like this. Phosphorus pentachloride would look like that. And sulfur dioxide we've already seen before. It looks like that. So let's finish up with a review table. And this will help you, this review table, if you get this down, and this is, I believe, in your book. You start out, if it's not in your book, it's in a book that I used in the past, and I think it's very useful. So you start out with the formula, and the first question you ask is this an acid or not? If it is an acid, you go along the right side here, and then you ask the question, does it have a polyatomic ion in it or not? If the answer is no, then it's a binary acid. And the name is very simple. It's hydro-whateveric acid, hydrochloric acid, hydrobromic acid, etc. If it is polyatomic, then there are 4 possibilities, okay, depending on the polyatomic ion in the table. The maximum negative charge starts with per, so perchlorate, and you change perchlorate to perchloric acid. You change chlorate to chloric acid. You change chlorite to chlorous acid, and hypochlorite to hypochlorous acid. Just as an example. Now, not everything has 4 possibilities. And the 2 that drop out are the top one, the per, and the bottom one, the hypo. So for example, if it's nitrate, then it's nitric acid. If it's nitrite, then it's nitrous acid. And so forth. Now, you really have to just do a lot of these so that you get used to the trend that goes on here. Now go back up to the top of this table and you see that if the answer is no, it's not an acid, then you have to answer the question, is this ionic or not? If it is ionic, then you have to answer the question, polyatomic or not. If it's not polyatomic, it's a binary compound, binary ionic compound, and its name is very simple. It starts out with the anion, has the IDE suffix, and the compound name is the cation. Then you ask, does it have more than one oxidation state? If it does, then you have to use a Roman numeral. Now, we didn't talk about hydrates, and I wouldn't worry about hydrates right now. If, on the other hand, you go down this polyatomic and it is polyatomic, then you have to use that what you know from the table in terms of how to name. No matter how often I talk about these things, this is one of the areas that requires practice. You just have to do a lot of these in your homework to get used to doing them. So if you do a lot of homework examples, it'll help you to keep this clear in your head.